All right. We are going to go through scatter plots, and there is going to be a confidence interval and hypothesis test that we're going to do for scatter plots. What I want to do today. What I want to do today. What I want to do today is I want to go through the conditions that you will need to check for these confidence intervals and hypothesis tests, because they're going to be different than the ones we have done in the past. Some of them are going to be the same, but some of them are going to be different. So I want to go through what the conditions are and how to check for them. There's going to be one or two of them that might not make complete sense to you yet. That's okay. But some of them should look familiar. Some of them are going to be new. And we'll go through more examples as we go through the next couple days. Here we go. All right. This slide is just saying that different samples will give you different scatter plots, which will have different equations and different slopes of those regression lines. And so one of the tests and intervals that we're going to be, these tests and intervals that we're going to be doing is about the slope of the regression line. So it's just setting you up that if I take, sampling variability, if I take different samples, I'm going to get different results, including X and Y and your scatter plots and your equations of the least squares regression line are going to be different depending on the sample that I take. And so there's a distribution that I could take of the possible slopes that we could get for that line, and here's what shape, center, and spread would look like. And for right now, what you would need to know is that those samples would follow an approximately normal distribution, which means that normal is going to be one of our conditions again. Here are the conditions. There's 5. Here they are. The ones that should look familiar to you. Normal, we're going to check a little bit differently than we have been. But independent should look familiar. Random should look familiar. And then there are 2 other conditions. One of them is linear. And hopefully we know from a scatter plot how to check for linear. We can either look at the scatter plot and see if it follows a linear pattern. Or we can look at the residual plot. And if the residual plot follows a distinctive pattern, especially if a distinctive curved pattern, then that spells trouble for us having a linear model. That tells us we have some other type of curve going on other than linear. So we want no clear pattern in the residual plot. Or we can look at the scatter plot and see if a straight line would be the best fit for the data. This equal variance condition is one that I want to explain very quickly. Now, they have this diagram here on the next slide that shows, that it should be evenly spaced out throughout the rest of it. So that's a visual of equal variance. So the variance, no matter where I am in the line, should be the same between the points. But let me just show, let me just draw for you a picture of equal variance happening and equal variance not happening. So here's an example of a yes for equal variance. So here's my line that fits the data. Here's an example of equal variance working out. Oh no, all right. Okay, here's an example of equal variance working out. Variance means, is a measure of spread. And so the idea is that as I go left to right across the line, the distance, the variance of the points away from my line stays roughly the same throughout. That's an example of equal variance. Here's an example of no equal variance. Here's same picture. Same line fitting the data. That is not equal variance. The reason that that is not equal variance is because here, the distance that the points are away from the line, pretty narrow like they were over here. But then as I move further to the right, notice that the points are varying a lot more than they are on the lower values of the line. So my variance of the points away from the line of best fit is not the same throughout the line. Another way you can show that, and you can see that, is by looking at the residual plot. And if the residual plot starts to look like the points are more spread out over time, if the residuals get bigger and bigger as I move from left to right, or the other way, they get smaller as I move from left to right, that's a clue that the equal variance condition is not working out the way it's supposed to. We'll do an example where we check the conditions. But a lot of this, a lot of these conditions are going to be using the residuals to check these conditions. The residuals or the residual plot. So we will talk tomorrow and review how to make a residual plot on the calculator, because we're going to need to know how to do that. But here is how to check these conditions. Pretend all the points got erased.
Why does the smart board have bullet holes in it?
Linear. To check the linear condition, you're going to either look at the scatter plot or you're going to look at the residual plot for a clear pattern. If you're looking at the scatter plot, you just want to look at a linear, if a line is the best fit. If you're looking at the residual plot, you want there to be no clear pattern in the residual plot. Independent, we check the same way we always have. Normal. The best way we're going to, the way that we can do this one is by making a normal probability plot of the residuals or some other kind of plot for the residuals that we usually use to check for the normal condition. And we are doing that for the residuals. On this example, we're going to have the graphs put out in front of us. And then on the next one tomorrow, we'll talk about how to make these graphs in the calculator. Equal variance, we just talked about. The best way is to look at the residual plot and see how the variance looks throughout. Random, check the same way we always have. Okay? So let's take a look at this example. Was there a question?
No, I'll just see if it's answered.
Okay. The suspense. So the way you can remember these 5 conditions is that the way they have to remember is that it's linear, but not quite. Yes. Or liner, or yeah. Yeah, not quite. Linear, but not quite. All right. Here comes the example. This one is scatter plot. This is the residual. plot. This is a histogram. Hopefully I don't have to label this. That's a normal probability plot. All right. Linear but not. So the L, linear. So I'm going to look at, the best place I'm going to look is the scatter plot. Does the scatter plot look like a line that's going to fit the data? Yeah, looks like a line is going to fit the data. So that's my linear condition. I, independent. I won't talk too much about that one because we know how to check independent. N, normal. Here's our normal probability plot. We want the normal probability plot to be fairly linear. Equal variance. This one's a little bit of a concern because we have these different, these like discrete different heights. And so we want the variance between those heights to be the same. And if I look at the residual plot, here's my range of values. And so we want this range of values to stay consistent throughout. Uh-oh, now it's getting a little wider. Now it's a little wider. Now it's way wider than it was. And now it's about where it was. So the variance is not quite staying equal throughout all of these. So the equal variance condition here is a little iffy because the variance between these is not the same. And then here's independent, random. They were randomly assigned to the 5 possible heights.
So if this were to happen in an actual problem, would we still be able to continue even though the equal variance isn't exactly where we want it?
Here's what they say. Except for a slight concern about the equal variance condition, we should be safe performing inference about the regression model in this setting.
Would you want
We would say something like that in the
So you
conditions.
would want to like note and put down like, hey, there's a slight
yes, yes,
bothering.
that's the idea.
Okay.
So how do we
So again, this is step 2. And these are going to be called linear regression t-tests and linear regression t-intervals when we do them. So we're going to use t-scores. So we're going to use t-scores to do this and the t-distribution when we do this. So that's step 2. That's your condition. We'll talk more about these steps, especially the formulas and how those work, and how to create these in your calculator. We're going to talk about that tomorrow.